Hi students, welcome back to my channel. In today's episode, we are kicking off a new chapter on straight lines in the coordinate system. Before we dive in, let's take a moment to review some key concepts we learned in Form 3, slope and inclinations. Learn the definition of slope in Form 3. The slope is divided as the vertical distance divided by the horizontal distance, serving as a tool to measure the stiffness of a line. It's important to note that the term slope refers to both the measurement of stiffness and the line itself. If we drag the point closer to the foot of the line, the slope becomes 4/5. It is clear that as the horizontal distance from line decreases to 5, the slope becomes deeper. It's reflected in the value 4/5 is greater than 4/9, indicating that the slope of the second line is deeper than that of the first line. Let's place the diagram on a coordinate plane and apply the definition of slope, which is the vertical distance divided by the horizontal distance. With the coordinates of the two endpoints A and B, we can see that the vertical distance is y2 minus y1, while the horizontal distance is s2 minus s1. Consequently, we arrive at the formula for the slope of a line in terms of coordinate. Slope is equal to y2 minus y1 over s2 minus s1. We also learned the term inclinations. It refers to the angle between the line and the positive direction of x-axis. This angle is often expressed in degrees, indicating the stiffness of the line. But how can we find the value of the inclinations? Actually, we can use the tangent functions from trigonometry for this purpose. Suppose that the inclination is represented by alpha, then tangent alpha is equal to opposite side, which is y2 minus y1, over adjacent side, which is s2 minus s1. So this ratio is equivalent to the slope. We can express the relationship between slope and inclinations as slope is equal to tangent alpha. To find the value of the angle alpha, we can take the inverse tangent, arctangent of the slope. In this particular example, alpha is equal to arctangent 4/9. Therefore, we have two different measures of stiffness, slope and inclinations. The slope is expected as a fraction, while the inclination is measured in degrees. It's important to recognize this distinction while discussing the stiffness of a line. Slope not only expresses the stiffness of a line, but also indicates its directions. According to the slope formula, a line with positive slope rise as you move from left to right. Conversely, if the line decreases from left to right, its slope is negative. A horizontal line has a slope of 0, while the slope of a vertical line is considered undivided. To illustrate why the slope of a vertical line is undivided, consider 2 points on such a line. If we test the 2 points with the same x-coordinates, the calculation for the slope would have a denominator 3 minus 3, which equals to 0. A 0 denominator results an undivided value, explaining why the slope of a vertical line is undivided. So far, we have the formula of slope, and also we know that slope is equal to tangent of the inclinations. Okay, in this question, find the slope of the following lines, express them in terms of surd if necessary. Okay, in part A, the inclination is 42 degrees. So the question asks us about the slope. So we can just use the formula. Slope is equal to tangent 42 degrees. Okay, so we find this value by the calculator is 0.90. One of the answer correct to 3 significant figures. Okay, in part B, we apply the same formula. Slope is equal to tangent 60 degrees. 60 degrees is a special angle, and the question requires us to use surd if necessary. Or perhaps we take some time to review the special angle of tangent. Tangent 30 degrees is 1 over root 3. 45 degrees 1 and 60 degrees is root 3. So tangent 60 degrees, the slope will be equal to root 3. In question 2, we also need to find the value of the slope by using the formula of the slope is equal to tangent alpha. But we need to bear in mind that the definition of inclinations is the angle between the line and the positive side of the x-axis. So the inclination is not 145, it's the angle next to 145. So perhaps we can express the inclination first. That's 180 minus 145, so that's 35 degrees. So the slope is equal to tangent 35 degrees, and then the result is 0.70. Again, the answer is correct to 3 significant figures. Okay, in question 2b, this angle is the inclinations. Perhaps we name beta and alpha. Okay, according to the diagram. Okay, beta is equal to 180 minus 90 minus 40. That's 50. Okay, so alpha is also equal to 50. The reason is vertical opposite angles. Okay, so slope is equal to tangent 50 degrees. Okay, so the slope is 1.19. In question 3 and 4, in the following questions, find the slope of the straight lines that connect the 2 points and their inclinations. Now we are given 2 points, so to find the slope, we can use the formula of y2 minus y1 over x2 minus x1. So that is 6 over 7. Okay, to find the inclinations, we can use arctangent 6 over 7. Okay, the answer is 40.6 degrees. Question 4, we do the same thing. Slope is equal to -1 minus 4 over 2 minus -8. That is 2 plus 8. So that's -1 over 2. The inclinations is arctangent -1 over 2. Okay, so according to the result of the calculator, that is -26.6 degrees. Now we obtain a negative inclination. How do we interpret this? Perhaps we go back to the definitions of inclinations. okay, is the angle between the line and the positive side of x-axis. Essentially, the inclination has a direction, perhaps right down in the right hand side. If it is anti-clockwise, it is positive. If it goes clockwise, it's defined to be negative. Time we have a negative 26.6 degree, and the diagram should be like this. 26.6 degree refers to the inclinations below the x-axis, 26.6 degree. Okay, so the inclinations alpha, okay, is equal to 180 minus 26.6 degree. So the answer of this question is 155.4 degree. Question 5, given the straight line that passes through E and F, determine the value of n such that the line intersects the x-axis at an angle of 30 degrees. The question gives us the 2 points, so we plug in the formula. We have the slope is equal to 3√3 over 1 minus n. And the question gives us the line intersects the x-axis at an angle of 30 degrees. The diagram should be like this, 30 degrees. Okay, so 30 degrees is the inclinations. So 3√3 1 minus n, that slope is equal to tangent 30 degrees. Tangent 30 degrees is equal to 1 over √3. To simplify these equations, we do the cross multiplications. So 3√3 times √3 is equal to 1 minus n, and then 9 is equal to 1 minus n, and then n is 1 minus 9, that is equal to negative. Question says, in the diagram, find the value of a. Okay, there are several things appear in the diagram. The first one is the 40 degree. This angle is 40. This angle should be 50. And then the vertical opposite angle is 50. So the first thing below that is the inclinations is equal to 50 degrees. Okay, next we have a point 41, and the y-intercept is a. Now please look that the y-intercept is actually has both x coordinate and y coordinate. X coordinate is 0, y coordinate is a. Okay, if we have 2 points 41 and 0a, we can use the formula to find the slope. The slope is equal to 1 minus a over 4 minus 0. Okay, that is 1 minus a over 4. Because we have the inclinations, so we can use the formula. Slope is equal to tangent 50 degrees. So 1 minus a over 4 is equal to tangent 50 degrees. And then 1 minus a is 4 times tangent 50. Okay, we can rearrange everything and then use the calculate once, and then it will give us the answer negative 3.77. Question 7, in the figure, slope of AC. The slope of AC is double of the slope of AB. Find the value of A and theta. A is the x-intercept of AC, and theta is the inclination of AC. Okay, the information is about the slope of AC is double of AB. So the first thing we need to find the slope of AB. To find the slope of AB, of course, we need to find we use either the inclination or use the 2 points. So far we don't have the inclination, so try to find out the 2 points. One of the points is 4, 3. The other points come from the x-intercept. We know that the x-intercept is 1, so we can assume, because the point lies on the x-axis, so x coordinate is 1, y coordinate is 0. Okay, so the slope is 3 minus 0, 4 minus 1. That is 3 over 3. That's 1. Perhaps we need to mention about slope of AB, because we are going to find 2 different slopes. Okay, so slope of AC should be equal to 2. If we know that the slope of AC, we can use the formula 2 is equal to tangent theta. Then theta is equal to arctangent 2. And then the angle is 63.4 degrees. Okay, now the coordinate of the x-intercept of AC should be equal to A0. Okay, to find the value of A0, we can use the 2 points, these 2 points. Okay, we put in the formula 3 minus 0, 4 minus A is equal to the slope. The slope of AC is equal to 2, so we put 2 here. 3 is equal to h minus 2a, so 2a is 5. A is equal to 5 over 2. We have reviewed the slope and the inclinations. In the next episode, we will start to learn the equation of straight lines. Okay, see you next time. Goodbye.